Good afternoon, student. I have here a setup in where I have a bucket, 5-gallon bucket right here, and this 5-gallon bucket will drain his liquid to this bucket that is down here. It's another 5-gallon full of water. As you can see, there is a submergible pump right there. That submergible pump is a 12-volt pump, and right now it doesn't have any control except that when I connected to this almighty power supply, what was this? Coleco. I have kept this power supply for very long time. For anything that requires 12 volts, is very powerful. Let's see how much amp can provide. About 0.3 amps. That might not be a big deal, but it worked perfect. So I'm using the 12 volt 0.3 amp connector in this power supply, and since I'm only powering on and off the pump, I don't care about the connection. It's kind of weird here. I'm using here the connector for the only for the 12 volts. I don't want to cut this off, this plug, so because this eventually will be modified to really have a very functional control over the pump. Right now it's on off, and I'm thinking what to do to properly control the pump. There's many alternatives. I can certainly use sort of like on off. Let's see if I have here something that I will show you. I can certainly use something like this. Let's see. This is like, see if I can focus this better. Yep, this is like a relay, and that would do the on-off. But remember, the problem is when you're controlling an inductive load like a motor, that would be a problem. I don't like it. Sooner or later, the motor will die out. So I'd rather, this is okay for kind of a pure resistive type of load, like you are heating something, that would be okay. And you can use duty cycle, like 10 seconds being the maximum on, 0 second off. So you can certainly do that. In fact, you can do that with the pump. The only problem with that is that the pump will not last, particularly when you are right at the set point where the pump might be on off too quickly, and that will damage the pump. So I'd rather use a different control scheme just for the pump. So we'll see. In the meantime, I only want to show you how the equipment looks like. Again, let me focus this better. So here is the Arduino. The Arduino definitely can measure the level. Right now it's on the negative side, and you will say, why is reading negative? Well, what happened is the hole in the bucket, the orifice, is not right at the bottom. The bucket right now is dry, and here is the sensor. So I'm using an ultrasound sensor, and so all this cable eventually go right to this box where is the Arduino is located. So the Arduino will be doing all the controlling when it has the other part. It's missing half of it. Basically, it has the part of reading the level, but it doesn't have the ability yet to control the pump. I will show now the pump. Just turn it on and see what happens, because the idea is that you, between the high level, let's say that the high level in this tank is somewhere, let's see if I can pull it, is somewhere here, and the low level is right at the orifice. You can take a look right here, show you. Here is where the orifice is located, right here. So the orifice will go right to this bucket, the water, and it will circulate. You will have a recirculation, and eventually you will have a level here somewhere. If you do this properly, it might be that two things happen. Either I arrive to a steady state level, or either I overfill the vessel, depending of the size of that orifice right there. So let's test this. Let's see how it behaves. So I'm gonna turn the pump, and you will see that in a second. Let me see if I can do that with one hand. Let me pull here the extension cord. So I will connect this right here, and while that happens, you can see the water start to pour in. Not a big deal. Now the reading, let's see. Let's see. Now it's going right to where. Let's keep watching the reading until it gets to the orifice. There we go. Now water starts to pour out, so I'm meaning that I'm right at the orifice, right there. So I have to put this a little bit back. Now the rate of water in might be higher than the rate of water out, and eventually that will be driving that elevation to a higher number. With the size of the orifice that we have right now, which I believe is about a little bit bigger than 1/4 of an inch, so the level is going up in centimeters. So yeah, the flow of this pump is about 35 ml per second, about half a gallon, I believe, half a gallon per minute. So the level is going up, and as the level goes up, you can see the water here coming up a little bit faster at a higher flow. Because it has a higher head of water pushing out through the orifice. Let's see. It seems that that orifice is very big for this pump. So we'll see. What's the level right now? About 2 centimeters. It's going up. Very slowly. So probably we'll have to reduce the orifice so that I can have a higher range of level to work with. So I can put a set point anywhere where I want it. Because at that flow rate, that's way too small. But that's the pump that I have. So it's a pump about $5. Okay, about $5. And so when I make what I will do is plug that hole and make a smaller one so that I can have again a better control of my tank level when I have the full control about the pump. Hello, well, I just finished plugging that hole back there, and I see if I can quickly take a look. I made a small one, very tiny, right where at the same height pretty much that the other was, not to affect too much the calibration, but I believe that I have to recheck that calibration to be sure that it's okay. But that's the tiny hole now. That shouldn't be a problem for me to control now the level the way I want it. So again, I plug it with hot glue right here. It did perfect. It looks like I put a little bit in the inside as well, so it shouldn't leak at all. We'll see. Let me turn on the pump and let's see how this works. Right now, since the vessel is dry, you can see the tank is dry, so it's reading negative value because I have to be at the plug at the whole side of the orifice. Well, let's connect this and let's see what happens. I'm connecting the pump, and yeah, being a small orifice, I don't know whether it will produce too much bubbles. In fact, it is not yet coming out of the orifice. There we go. Now it's coming. So the level is rising very quickly. So let's see how well now it behaves. My expectation is that it gets right at 14 inches of this tank. Let's see how the level looks like. I have to adjust this. It's going for the 4 centimeter now. So smaller orifice should work better. Again, let's try to avoid the formation of bubbles. So let me put here, hold for 1 second. Yep, put the lid back again to avoid bubbles. And so you can see the orifice doing his work, but the pump is doing his work as well. And now I'm going to be hitting a higher level of equilibrium eventually. Let's see. It's moving to the 7. So, whoops, 0.6. Where'd that come from? Oops, there's a problem with the sensor. That was strange. Yeah, I'm moving the vessel because it was not located properly with respect to the sensor, so I need to check that out. But basically it should hit about 30 centimeters, and that would be so I think it wasn't properly set, the ultrasound, with respect to the tank. Let's hold for 1 second here. So definitely it's going up. Hitting the 19 centimeter, no more glitches. How about here? More pressure. pressure, so the water cannot travel longer distance for into the tank where the pump is located. I will change a little bit of that, but in the meantime it's doing his job. So far so good. So again, the idea is that I will be able now with that new orifice, I will be able to control the pump without the on and off. I can put some offset at the pump, you know, that at a given level start, at a given level stop, you know, but I want full control. So I will be using more like a MOSFET with a filter. We'll see. That's what I have in mind. I'm planning to do. And let's see where we are. We are getting closer. Let's see what the level said here. Almost 23 centimeters. And rising. Good. Let's see where this equilibrium show up between what's coming out and what's coming in. Hopefully it will be an equilibrium. The idea is that I want the equilibrium to be higher than the vessel maximum height, which is about 14 inches. We'll see. Well, this is it. This is process control at its best. Input, water input through one side, water output through the other side, and eventually we will do some process control by adjusting that water flow to whatever level to whatever elevation I want in the vessel. So that will do. Yeah, almost there. Let's see. "28 centimeters, 29. It's a little bit higher right now than the 5 gallons mark. This is this is a bucket for paint, so it's getting close. Yeah, 31 centimeters. That's good. Plenty of water. Then I have to stop right there. I'm stopping right now. Put this in. Well, I stopped the pump. The level was right at the. Let's see if I can take a look here. About an inch from the top. So the reading is about 31 centimeters. That's above the orifice. Okay, right now the tank is being drained through the orifice, hitting the bucket lid and falling back to the vessel. But the pump is at this point is disconnected. So definitely I can, with this setup, I can set now the proper control for having some software coding the proper control for the pump. And for that, I'm planning to use a MOSFET. And you will see the many things that we can do with that. Again, really, this is just process control. I mean, this is the first part of it, just having a working system that can do the height, the highest elevation that I can handle here without any issue. That would be about 13 inches or so, about 31 centimeters. And I have to redo the clock. The original orifice was way too big. This was just for another purpose, but now that I want to do full control, and let me check. I'm checking now if there is any leak through the original orifice, and it looks perfect. I mean, that hot glue really did the job. No leak whatsoever. There's glue inside as well. So here is a tiny orifice that is doing the drainage. Alright, that will do for now. Again, thank you a lot for watching. I appreciate it.